Hello everyone, welcome back to Under the Apple Tree, and today we're going to be going over some position functions, velocities, and accelerations. How are they related, and how can we solve some problems that will be commonly asked about this idea? Okay, so our question is, the position of the moving particle is x of t is equal to 2t cubed minus 2 squared plus 11. And then at t equals 2 is the particle speeding up or slowing down. Now this is kind of a weird question if you've never seen it before, and I'm going to shed some light on it. Basically, if the acceleration and velocity have the same sign, the particle speeding up, it doesn't matter what the sign is. They can both be negative, they can both be positive, but as long as it's the same, it's speeding up. If they're different, if acceleration is positive and velocity is negative, then the particle is slowing down. So that's what you need to know for that part of the question. Now this other half is kind of like, we have position and how do we get velocity and acceleration? Well, hopefully by now you know that they're just the derivatives of each other. So velocity is the derivative of position. So let's get our velocity since we know that. V of t is equal to, simple derivative here is going to be 6t squared minus 2t. What's nice about these is the derivatives get easier and easier as you go. So now let's get acceleration. That's just going to be 12t minus 2. You could factor out a 2 in both velocity and acceleration, but it doesn't really matter too much. Your math isn't going to be very complicated anyway. Okay, so let's see if this is speeding up or slowing down. So let's find velocity at time t equals 2 first. So v of 2. This is pretty easy. All you do here is just sub in a 2 for t. Minus 2 times 2. What's our answer going to come out to be? 2 squared times 6. It's going to be 24 minus 4. It's 20. And so it doesn't matter what our value is. Our specific value isn't important here. What's important is that we have a positive number. So let's, oops, meant to highlight that. So let's highlight this here. Positive number for velocity. That's good. Now let's do acceleration at times 2. A of 2 is equal to 12 times 2 minus 2. And we can already see it's going to be positive. 2 times 12, 24 minus 2, 22. Like I said, the specific values don't matter. This is going to be highlighted, both positive, and it's a good idea to write down your units, meters per second squared, meters per second. Okay, so now we know they're both positive, therefore it is speeding up, not slowing down. So we know the particle is indeed speeding up. That is correct. Now another important idea that I'm going to show you for position, velocity, acceleration is how you can go about finding maximums. So for example, let's say somebody says, oh, here's the velocity function. Or not even, it's usually like the position function or anything. But you need to find at what time and what value is the maximum velocity. So let's go over to our graphing over here, and this will help shed some light. So let's say that this red graph here, that's our velocity function. And so if you're given this graphically, it's pretty obvious. It's easy to see, oh, this is clearly a max at 0.5, you can just look and see. But if you're not given it graphically, how do you solve this? So I put in this green line here to show you the importance of the slope at the maximum. So the vertex here is the maximum of velocity. Hopefully we can agree on that. And this slope, or this line, is the slope at that maximum point. And so the slope of a horizontal line is just 0. Why is this important? Because we know the slope of the maximum is 0. So what does that mean? That means you can take the derivative of this red function, and then set that derivative equal to 0. And then you'll get a time value. That time value is the time at which velocity is maximized, or whatever your function is. Anyway, I hope this was a lot of help for you. Good luck on your exams and homework. See you next time.